So complex numbers are written in the form a plus bi. So when we write our answers, we'll need to make sure that they're in that order, with the real part first and the imaginary part second. When we add and subtract complex numbers, first we need to identify the real parts. So we have -2 and 3, and then we need to pay attention to the operation in the middle we will be adding. So we're going to add -2 plus 3, which is 1. Then we'll add the imaginary parts, which is +4 plus -11i. So when we do that, we get -7i. The real parts first and the imaginary parts second, so we're done. In 4b, 4 is the real part. We're going to add on 5. So 4 plus 5 is 9. Now for the imaginary parts, -1i plus 8i. When we do that, we get +7i. The real parts first, the imaginary part second, so we're done. In part C, we need to subtract these problems. So we'll take the real part, -4, and we'll subtract 2. -4 minus 2. The minus sign comes from the middle. That gives us -6. Then we subtract the imaginary parts. So we'll have 1 minus -9. And those are i's. So the minus negative turns to a plus, and 1 plus 9 is 10i. Final answer. Last, we have 1 minus 9. 1 minus 9 is -8. And we have -1i minus +3i. So -1 minus 3 is -4i. For multiplying, we do everything we normally would as far as distributing and FOILing, but whenever we see an I squared, we're going to replace it with -1 inside parentheses. So I'm going to show you D first. This means that we have 3i times 3i. So 3 times 3 is 9. I times I is I squared, and we're going to replace the I squared in parentheses with -1. So 9 times -1 is -9. Now let's try A. We'll do 2i times 3 and 2i times -5i. So first we'll get 6i. 2 times -5 is -10, and I times I is I squared. I'll recopy the 6i, recopy the -10, and for the I squared, I'm going to replace it with -1 in parentheses. So our next step will be to multiply the -10 and the -1. So we'll have 6i plus 10, and now we just need to flip-flop those so the real part's first and the imaginary part is second. So that's our final answer. When we look at B, we do the same thing to distribute. 3 times -3 is -9 with an I. 3i times +2i is +6i squared. I'll recopy the -9i and the +6, and I'll replace the I squared with -1 in parentheses. So the next step is to multiply those two together. So we have -9i minus 6, and our final answer, we need to flip-flop them, so the real part's first, so the -6 is first, and then the -9i. On C, we need to FOIL. Remember, FOIL stands for first, outer, inner, last. So let's multiply the first two numbers in the parentheses. 3 times 2 is 6. Next, we'll multiply the outside numbers. 3 times 4i is 12i. Now we'll multiply the inside numbers. -5 times 2 is -10i. And now for the last numbers. Negative 5i times positive 4i is negative 20i squared. So it looks like we need to combine some like terms. So we have 6. The 12i minus 10i gives us 2i's. I'll recopy the minus 20, and I'm going to replace the I squared, in parentheses, with negative 1. So 6 plus 2i, when we multiply negative 20 times negative 1, we get positive 20. And the last step is to combine the like terms, 6 and 20. So all together, that's 26, and that's the real part. And then we'll write the 2i after it, because that's the imaginary part. When we need to simplify powers of I, we have to first check to see if we have an even power or an odd power, because we treat them a little bit differently. If we have something raised to an even power, we're going to rewrite it using I to the second, and then multiplied by whatever we need to multiply the number by to get our even number. So if we had, for example, I to the 10th, we would rewrite it as I squared to the 5th, because 2 times 5 is 10. Then we would replace the I squared with negative 1, and then figure out what that equals, depending on what our exponent is. If we start with an odd power, we need to pull one of the i's out, and we'll put it right there out front. Then we write the rest of it using I squared to whatever's left over. So for example, if I started with I to the 11th, I'd pull out one of the i's, so that way I'd be working with I to the 10th, and then I would recopy the I out front, and I'd rewrite it as I squared to the 5th, just like on the other side. You do need to remember that if you raise negative 1 to an even number, the answer will always come out positive 1, because there's an even number of negative signs and they will all match up and become positive. If you raise negative 1 to an odd power, the answer will always be negative 1, because there will always be an odd number of negatives. So let's try these. In A, we have I to the 12th. That's even, so I can right away rewrite that as I squared, which would be 2 times 6 to give us 12. So I'll replace the I squared with negative 1 to the 6th, and anything to an even power is positive 1. When I look at B, I see 25 is an odd power. So I need to first pull that I out front, and then I'm left with 24. So I'll recopy the I out front, and I'm going to rewrite 24 using I squared. So 2 times 12 gives me 24. Now I'll recopy that I again. In for the I squared, we'll replace it with negative 1 to the 12th. So we have I times negative 1 to the 12th is going to be positive 1, and I times 1 is I. Let's try C. When we have a number out front, we're just going to recopy it and kind of save it until the end. I do notice that 23 is odd, so we need to pull out one of the i's, and when we do that, instead of working with 23, we'll be working with 22. So we figure out I to the second to the what power equals 22? Well, 2 times 11 gives us 22. So I'll recopy all of this. We have 2i out front. We'll replace the I squared with negative 1 to the 11th. So we have 2i, and negative 1 to an odd power is going to be negative 1. So 2 times negative 1 is negative 2i. On D, we'll start it the same way. We'll recopy the negative 8 out front. 16 is an even power, so I can go ahead and rewrite it using I squared to the 8th, because 2 times 8 is 16. Recopy the negative 8, replace the I squared with negative 1, and I know negative 1 to the 8th power, since that's even, will be positive 1, and negative 8 times 1 is negative 8. Alright, you might be getting the hang of these, but I'll still go through the rest of them, just to be sure. But I'll do them maybe a little bit faster. We'll have negative 2 out front. I to the 10th can be rewritten as I squared to the 5th. So we'll have negative 2 times negative 1 to the 5th, which is negative 2 times negative 1, which equals positive 2. So that's for E. On F, we'll have 3, and I'm going to pull out an I, so that instead of 19, I have 18. Then I'll rewrite that as I squared to the 9th, because 2 times 9 is 18. So I'll have 3I. I'll replace the I squared with negative 1 to the 9th. So I'll have 3I. A negative 1 to an odd power is negative 1. So the final answer is negative 3I, because you multiply the 3 and the negative 1. On G, we'll have negative 12. This is even, so I can go ahead and rewrite it using I squared to the 11th, because 2 times 11 is 22. So I'll have negative 12 times negative 1 to the 11th, which will be negative 12 times negative 1, which is positive 12. So that one's G. Last, I'll fit H right here. Negative 12. I to the 23 is odd, so I'll pull out one of the I's, so I'm left with 22. I'll rewrite using I squared to the 11th, because 2 times 11 is 22. So I'll have negative 12I times negative 1 to the 11th, which is negative 12I times negative 1, because that's odd and it will equal negative 1. And last but not least, negative 12 times negative 1 is positive 12 with an I. There's one pattern you may have caught on so far, but the powers that start off odd will all have the I's in the answer, like H and F. But all the examples that start out with even powers will not have I's in their answers, so like E and G. In order to divide complex numbers, we are going to multiply on top and bottom by the complex conjugate. So we actually learned it for a reason. In letter A, the complex conjugate of the denominator, just of the bottom. All right. So the complex conjugate of positive 5i is negative 5i. So we'll multiply on bottom by that, and we'll multiply on top. So we have to multiply all of that. So 3 times negative 5i is negative 15i. Negative 5i times 10i is negative 50i squared. We'll simplify that in a second. On the bottom, 5 times negative 5 is negative 25, and I times I is I squared. All right, let's simplify. We for sure can replace that I squared with negative 1 and that I squared with negative 1. So we'll have negative 15i minus 50 times negative 1. And we'll have on the bottom negative 25 times negative 1. So you can see real quick what's going to happen. Negative 15i. This is going to turn into plus 50. And on the bottom, that turns into positive 25. We're almost done, but we need to do a little bit of rearranging to get the final answer. First of all, we need to put the real part first. So the real part is going to be the 50 divided by 25. 50 divided by 25 is 2. I'm going to write the final answer over here. Now we need to simplify this to get the imaginary part. When we reduce 15 and 25, we can divide both of them by 5. So when we do that, we will be left with, it's a negative divided by a positive, so our sign will be negative. On top, we'll have 3. On bottom, we'll have 5. And we'll have the I next to it, and that's the final answer. Let's try B. We'll start off by finding the complex conjugate of the bottom, which, if we have negative I, will be positive I. So we'll multiply on top and bottom by that. So we have to multiply everything. 3 times I is 3I. 8I times I is plus 8I squared. On the bottom, negative I times I is negative I squared. So same next step, we're going to replace those I squareds with negative 1. And if you can already tell what's going to happen, the sign's basically going to switch. We'll have 3I, and then since we'll put a negative 1 right there, positive 8 times negative 1, that's going to be negative 8. On bottom, if we stick a negative 1 right there, we'll have negative 1, and that's going to turn into positive 1. We don't really need to write divided by 1 for all of those, but we do need to write our answer with the real part first. So the negative 8 will be first, and then the positive 3I will be second, and we're done. Alright, these might take up a little bit of room, so in order to keep the top and bottom separate, I'm going to write the bottom in blue. So the complex conjugate of 4 minus 2I is 4 plus 2I. And then on top, I'll write 4 plus 2I in pink on top. So on the top, this will all equal. We need to FOIL those together. So 2 times 4 is 8. 2 times 2I is plus 4I. 8I times 4 is plus 32I. And 8I times 2I is plus 16I squared. That's the top. Now I'll write the bottom in blue. So I'll FOIL the bottom. We'll do 4 times 4 is 16. 4 times 2I is 8I. Negative 2I times 4 is negative 8I. And negative 2I times positive 2I is negative 4I squared. Now we need to combine like terms and reduce some things. So we can combine those. So on the top, we'll have 8. 4 plus 32 is 36I. And we can replace this with negative 1. So just to save a step, this is going to be positive 16 times negative 1. So it will become negative 16. So negative 16. Now I'll simplify the bottom. These are like terms, so we can combine those, and we'll replace that I squared with negative 1. So what we will end up with is the 16. The positive 8I minus 8I cancels out completely. And when we simplify negative 4 times negative 1, we'll get plus 4. So now let's keep going and combine like terms. 8 minus 16, that's going to be negative 8, plus the 36I. And on bottom, 16 plus 4 is 20. The final step is to divide the negative 8 by 20 and simplify it. So when we do that, we can divide both of those by 4. And so negative divided by positive is a negative. 8 divided by 4 is 2. 20 divided by 4 is 5. Next, I'll simplify this. It turns out that 20 and 36, the biggest number we can divide both of those by, is also 4. So 36 divided by 4, on the top, we will get positive 9. On the bottom, 20 divided by 4 is 5. And we'll have the I. So the real part's first, the imaginary part second, and we're done. Alright, last example. The complex conjugate of the bottom is 2 plus I. So we'll multiply on bottom in blue, and we will multiply by 2 plus I on top. So, on the top, we will get 3 times 2 is 6. 3 times I is 3I. Negative I times 2 is negative 2I. And negative I times I is negative I squared. Now underneath, we'll get 2 times 2 is 4. 2 times I is plus 2I. Negative I times 2 is negative 2I. And negative I times positive I is negative I squared. So let's combine like terms and simplify these. On the top, we can combine those like terms and replace that with negative 1. On the bottom, we'll combine like terms and replace that with negative 1. So let's simplify. We'll have 6. 3I minus 2I is just 1I. So I'll put plus I. And negative 1 will be positive 1. On the bottom, we have 4. Positive 2I minus 2I is going to cancel out. Will they always cancel out on bottom? Yes. If you don't get them to cancel out, you're doing something wrong. Last, we have negative 1, which is plus 1. So back on the top, let's combine the 6 and the 1. That's the real part, so we should write it first. 6 plus 1 is 7, plus I. And on bottom, 4 plus 1 is 5. Now we just need to simplify these parts. 7 divided by 5 doesn't reduce any further, so the real part is 7/5. And 1 divided by 5 doesn't simplify either, so we have plus 1/5 I. Do we need to take it to this step and write our answer like this rather than leave it like that? Yes, we should, because we do need to make the division by showing that we have the real part and then showing that we have the imaginary part. Good luck on your homework. Oops.